So what we have here is another classic AEG, probably 1970s, 1980s vintage power tool. And no joke, this case literally weighs, I'd say, over 60 pounds. I'm not exaggerating when I say that. So what's in here is actually one of their higher end drill models, the PhD 38. So as you can see, this thing's fully loaded. Not only the drill, but a ton of accessories. And some of these accessories are worth quite a bit of money. I think I got a steal on this. I paid, I think it was around $40 plus another $25 for shipping because it weighs so much. So I mean, it was under $75, which I think is still pretty good for what you're getting here. So each of these tubes is one of the drill bits, and this uses a spline system, which is not a very common system, so that's why these are kind of expensive to find. They do make actually adapters now to go from this to the more common SDS system. So it's not quite the end of the world if you can't find the drill bits. But let's take a quick inventory here of what bits we actually have in the set. So this actually says it says B&D, which I think is Black & Decker, right? 5016D, West Germany. So it's made in West Germany. I didn't know that Black & Decker made power tools in West Germany, but I'm guessing that's what that B&D is, unless it's something else. So all these tubes actually they kind of had a two-part system, kind of like you get the end mill bits these days, those type of cases. So it looks like a couple of them might be missing. You only have the one half. So you look at this beast right here. I'm going to put on some gloves because most of these are actually oiled. So it was pretty well maintained. So this one, it says made in Italy, 13186B. That's a heck of a bit there. So these look like the genuine AEG tubes as well. And this is why it was so heavy, was all these accessories that they included. So this is another made in West Germany. And this is a genuine AEG one. It says 3/4 on it. And then we have looks like a Bosch chisel driver. This one actually says made in USA on it. It looks like we got a piece of cold rolled steel there. It looks like it came off a lathe, and I don't think that goes with this. So we got, so here's another Bosch 3-inch scaling chisel. And then we got, this has a little bit of attachment on it. I'm not sure what that's for. Here's another AEG. This one's a 1-inch. And we got, well, look at the size of this guy. Now, I can't imagine how much this cost back when they bought it, but it had to be a lot of money to buy this particular bit. So this is a 1.5-inch hammer drill bit. It looks like it has the carbide tips on there as well. And that is another genuine AEG one made in West Germany. So there's the actual official AEG tubes. It looks like a lot of them only have half the tube, so they must have lost a couple of them at one time. It's like, and it looks like we got a couple of rods here. I'm not sure if these actually go with it. They kind of look like guide rods. And then here's another smaller one. So this is a 1/2 inch made in West Germany. Still got some more over here. So that's a pointed chisel. Looks like it's got a little bit of surface rust on it. So what else we got? It looks like we got somebody's grease rag. Got 2 of them in here. Great. Here's another piece of that steel. That looks like this was a trash can at one time. We got some leaves and stuff in here. We got some old rusted screws up here too. So it's kind of cool how you see here the foam actually stayed on, or they maintained it. But this is really why I wanted to get this particular model. I've been trying to only buy these when they actually have the documentation with them, because then it gives me a chance to actually scan them in and share it with you guys. We'll take a look at that in a second. And then finally, looks like we got the drill. So the drill is not really that heavy compared to those bits. Before we go diving too far into the drill, let's go ahead and take a look at the documentation that is included here. So here we go. Now we're getting into the good stuff. This looks like a brochure. There's a date down here. 1984 was when they took the picture for that cover, so it had to be after that. So judging from the other information included, I would guess that this was bought around 1987. So this is really when they were at their height. So wow, this is all very cool stuff here. It's another basically catalog. So what we're looking at here is the PH38. Here's the actual flyer for that model, PH38, which is the one we're looking at today. So what's interesting is that P actually stands for pneumatic, PH. So pneumatic means air, so it must be generating some kind of, there must be some kind of piston in there that generates an air pressure in order to act as a rotary hammer, because there is no air inlet. It's not an air tool. And they kind of show it down here how that works. So yeah, it actually uses kind of a camshaft to drive this piston. So it must require that to be an airtight seal there. So on the backstroke, it must open up a check valve in order to let air back in, and then once it starts going the other way, it closes that check valve and uses that air pressure to actually hit the bit. So instead of it being just like a solid piston hitting that bit, it must be using the air pressure as well. It's right here. After the piston reverses direction, compressed air moves the percussion body forward to strike the drill bit. It's very, very interesting stuff. And so here are all the P models, which are all the pneumatic rotary hammer models, and we're looking at the PH38 today, which is right here. And there's your capacity, 1.5 inch. So no load speed, 550 RPM. It can do hollow core cutters up to 3.5 inches, 800 watts, weighs 13.5 pounds. And so here we go. This is the kind of stuff I'm looking for, the actual part schematic. And so I'll definitely scan all these in, put them on the website for anybody who's doing a restoration or needs to repair one of these. It's hard to find this kind of information. So we can look at some of the other tools they got here. They got the screwdrivers, circular saws, reciprocating saws, hedge trimmer, sanders, planers, and jigsaw, grinders, shears and nibblers, impact wrenches. Wow, that's a new one. I've never seen any AEG impact wrench before. So very, very cool stuff, getting this old documentation. So here is the actual operating manual for that unit. So there's probably not too much that you guys are really interested in here. I'll scan this in for those that want to read into the manual a little bit. Looks like it's all these service stations on this one. Is that really how you spell Canada? That's the first time I've ever seen that. Alright, so now onto the main drill here. So this actually does look in pretty good condition. I see a couple of issues. You can tell that the grease was starting to separate, and leaking out the seals a little bit, but it's to be expected for a tool this old. I doubt it's ever been serviced. So we got the rotary and the hammer only switch, which appears to be pretty smooth. So I think we'll go ahead and plug it in and see what we're dealing with. Let's see if we make sure everything's still working properly. So it just kicked up a bunch of dust. So obviously it's been turned on in a long time. So if this really is a hammer, drill, this thing is quiet as all heck. So it's possible that the hammer is not working. Alrighty, so let's go ahead and tear into this thing. So generally the first thing I do is I take the carbon brushes out. I would have expected them to be down here, but we'll go ahead and, this cover seems like it's the most likely place for those. So we'll go ahead and take this cover off, see what's in there. So yeah, those actually have thread locker on them. So either that was done at the factory or somebody's serviced this, and I have the feeling it's somebody serviced it. I've never seen any of these AEG tools have thread locker on any of the screws before. So it doesn't look like that was the carbon brush compartment. It looks like that was actually the adding of the grease compartment. So I think what I'm going to do is I'm going to put this back on. Boy, that's a strange smelling grease. It almost smells sweet, like chocolate, caramel, reddish color. So I'm going to pop that back on. Just save the messy part for later. So we'll go ahead and get rid of this handle. This is a piece that always seems to be missing on all these old drills. People break them or lose them. That's a actually pretty cool design there. I don't know if I've ever actually seen a design like this before. So like how they have the part number stamped in there. So that looks to be some kind of die cast. It's not soft enough to be aluminum. I think it might be some kind of zinc or magnesium. So that is a 6mm pin. We'll go ahead and take the clamshell handle off. Looks like we first got to take off these 3 socket cap screws and these 2 Phillips right here. So I'll go ahead and take off the rest of these socket cap screws. So I did look in the manual to see if there was a disassembly procedure, and of course there wasn't. So we'll just have to feel our way around it. Alright, so that comes off as a unit. You can't take off only part of that. So this machine is actually very clean. It doesn't even look like it was used that much. I mean, you can see the label here. So it was it could have been used, but it was stored properly in, low humidity environment. So you can see here we got our wires going to the field windings through the switch. This is a pretty standard construction. It looks actually very similar to that Vocker that we did not too long ago in terms of this clamshell design. It is interesting, they do actually have a real grounding screw. So that screw must go all the way through because this right here is plastic. So we'll go ahead and take that one screw off. So if it was used, it was used, it wasn't abused. Whoever owned it took very good care of this. So we got another Marquardt switch here. This looks like it's a 10 amp, 250 volt. And there's the date code right there, 486. So that puts this around the 86, 87 manufacturing date. So everything looks pretty good there. And they actually use real ferrules on the wires. That's good. Okay, so now it looks like we can go ahead and take this cover off. So these screws seem kind of loose. So there's the carbon brushes. So it looks like to get them out, we have to first take off, this little, it's a retainer. So it looks like those things are probably, I'd say, half gone. So it looks like next there's 4 socket cap screws here that appear to be holding in this plastic housing. If we take those off, that should release that. Looks like those are slightly longer than the other ones. Okay, so let's see. So wow, that came out really easy. But look at that bearing. How much you want to bet? I bet you that's a GMM bearing. Let's see what we got. So the manufacturer must be on the other side of the bearing. Doesn't look like there's too much here. The rest of this, we just got this air diverter. Yeah, it should just push right out. Wow, that's interesting. I've never seen this before. Look, there's actually springs here. I guess that's to dampen the vibration. So yeah, they do come out. Those look to be in almost perfect condition. So I'm looking at this schematic, and I'm afraid that there might be a circlip up in here holding that shaft, and I bet you that's what this compartment was originally for, was to get access to that. So I don't think that I can pull this out quite yet. So I think the next thing we're gonna have to do is actually start pulling these screws, pull this shaft out, and that way we can get a better look inside. So before we do that, we'll go ahead and see if we can pull this screw off. Looks like we got a little circlip there. That circlip just kind of failed on me. Yeah, that basically just overstretched, so I'm gonna have to replace that one. Yeah, I've never smelled it. I've never smelled grease like this before. It definitely smells like a chocolate caramel. So next I think I'll take out these 4 socket cap screws and see how that comes out. It looks like there's going to be more socket cap screws underneath of that, right behind this plate right here. Yeah, definitely use some kind of, looks like they were using the red thread locker. That's a permanent type. Alright, there we go, finally. Yeah, those bearings feel pretty good. So I don't think I'm even gonna take this assembly apart. I think it's fine the way it is. So what else we got? So we got a little spring washer here. Yeah, it actually looks like we got a couple more. Yeah, see this grease, how watery, or it's not very viscous at all. Yeah, see, it's almost dripping out. Looks like we got a little seal here. It looks like the gasket that was on there is pretty much destroyed. That's why why it was leaking a little bit. So we'll have to find a solution for that. So right down here is where the spline drive is for the bit. So this grease does look like it protected all the parts very well, whatever type it is, because they all look pretty pristine. So, wow, this is a really complicated assembly here. Here's a little needle roller bearing on this shaft here. Now it looks like we got a bearing shim right here on this shaft. Wow, this would have been one heck of an expensive drill. I mean, if you look at this piece, there is a shaft in the middle there. It's not all one piece, but if you look here, this gear is not pressed onto the shaft. It's actually part of the shaft. So they turned, I guess they would have probably turned this down first and then made this gear. But I can't imagine how much that costs for just this one piece to make. It looks like that's where the hammer would hit for your bit, transfer that energy. That came out pretty easily. The spline is actually all part of this piece, so they must have broached that out there. I don't know if there's any other way you could have, because there's no way you could have done that. It's not precise enough to be cast, or it's too precise to be cast. So yeah, I think that's how they did it, is they broached these splines out. And wow, this thing has some weight to it, this little piece right here. And it does look like there's a little O-ring on there. So that must be how it maintains the air seal. But yeah, there's another piece that's a solid piece of steel. So what else we got here? So it looks like we got two socket cap screws here. So that must be holding in this assembly. But before we do that, it looks like this wants to come out. So that looks like a kind of a bushing, and there is an O-ring on this piece as well. So that must be the other half of the air cylinder. They must have had the lathes open, working overtime to make these drills. Look at this. Ooh, yeah, these definitely have some Loctite on them as well. So now we got that. We'll go ahead and pop this cover off again, just to make sure there's nothing holding us back under here. There is like a gasket under this one. It's so old that it's like baked on. So let's see if we can pop this guy off now. Yeah, it's coming. So there's your main air generating piston. And that's probably what these holes are for, is actually to let the air in. So it looks like we can take this this camshaft off. That's kind of surprising that I didn't use a bearing here. Looks like they're just using a bushing. So looks like there's just a little clip holding this in. So it's not like a circlip. It looks just like a little piece of metal in a groove. You gotta be real careful. Yeah, I guess there's a name for those. Maybe like half C-clips or something. It looks like they pushed in a like a kind of a bushing, hardened bushing in there. And then it looks like we got another O-ring on here. So that's what they call a double X O-ring. Looks like the camera cut off there, but the only thing I did was I took off this piece right here. There wasn't much to it. There's a bearing in there. It looks like it's an NSK made in England. I don't see many English bearings around anymore. If you look down in here, it looks like there's some more socket cap screws right here. Alrighty, we got this assembly out. So let's see what we got here. So this is kind of like a retainer, it looks like. Then we got a bearing on here. So part of the reason why you're seeing like the grease here is thicker than it was in other places, that somebody might have added some incompatible grease and they didn't mix right. So we got a Koyo bearing made in Japan. So I'm pretty sure that this was rebuilt. Somebody rebuilt this drill, because I've never seen a Koyo bearing in any other AEG product before. But whoever did it did a pretty good job putting the Loctite on all the screws. And so after struggling with it for a little bit, I was finally able to get this next piece out right here. Take a look at them, but you can see the consistency of the grease has changed quite a bit as we get into the center compartment. So we're still not quite there. Still got to somehow finish getting the armature out. One of the things I did do is I scanned in that little parts diagram. And I blew it up on a 11x17 so I can actually see what I'm doing, because we still have to get somehow into this assembly to get that, what I think is going to be a circlip under there. So I'm definitely not seeing any circlips or anything in there, so this thing should just punch right out. Alright, got it out. And that's another NSK from England, 6001. It looks like there's a small shim right there between the. So that's it looks like that's just a bearing shim to ride on this surface right here. And it looks like this just pops off, Looks like it's keyed in there with some splines, as you can see here. I think that's about as far as I'm going to go with this armature assembly. This bearing on the end seems fine. I think I just need to clean this. I think I probably should pull this bearing out because it looks like there is some additional hardware underneath of there. Alright, so we got that one out. So that is a double sealed bearing, which is kind of unusual, and I don't usually see very many of those. I guess because it's not really in the grease compartment. Well, it kind of is, because there is some grease getting down in there. So, but we'll keep the same type because that's the engineer obviously wanted it to be that way. So underneath of that we have another bearing shim, and then it looks like there's an O-ring under there as well. And you can see the consistency of the grease down in that compartment is totally different from the stuff that we were pulling out before. So that's sort of what what I mean by incompatible grease. You often get these separations. So that's a very cool piece of engineering here. So if anybody actually ever owned one of these, please leave a comment below, because you don't really see it. You didn't really see this become very popular, this style. But this may also be another one that I decide to 3D model, even though I have the parts diagram. I'm kind of more interested in knowing how everything reacts with each other, all the mechanical interaction, because you have this basically drive line right here, but you also have alternatively another one down here. Alright, well I think that's going to wrap it up for this one. I'll catch you guys next time.